Alright, so let's work on this ACT. We have already started it. We're on number 31. Hoping to do the next ones today. ACT does go easy to hard, so these should be harder than the other ones. But let's see, it doesn't start out hard. So here, don't get tripped up. This is just like an SAT question. Don't get tripped up by squaring both sides like that, because that is not legal. All you got to do is say, what is the square root of 9, and what is the square root of 36? And there you go. That's all there is to it. All right, so we're getting into sine and cosine. So in the right triangle ABC below, the length of BC is 12 feet. They label it already. The sine of A is 3/4. What is the length in feet of AC? All right, so remember sine and cosine and tangent. So sine is opposite over adjacent. No, opposite over hypotenuse. So when they tell us this here, they're telling us that, like, if this was 3, this would be 4. But notice how this is not 3. This is 3 times 4. It's 12. So that just means that this is not 4, but it's 4 times 4. So this side is 16. And then if you know that that side is 16, I would just use Pythagorean theorem to find the other side. I'd take a guess that it's h, because it seems like it's going to have a square root. Because now if I call that x, it's going to be x squared plus 12 squared equals 16 squared. So then, whoa, what's 16 squared? 128? That's wrong. 256, I mean. 12 squared is 144. So you subtract those. You could also do this in your calculator, I guess. You get 112. And then what's 112 divided by 7? Just because that's what the answer is. 1, 4, 7, 4. Oh my gosh. 2, 6. Yeah, so 112 is 16 times 7. So the square root of that is 4 root 7. Yeah. So I feel like part of the trick here was they wanted you to do a 3, 4, 5. But it's not a 3, 4, 5. Because the hypotenuse is the 4. If this was tangent, then it would be a 3, 4, 5. But it's not. It's sine. All right. Ooh, back into logs. So 3 times log base 2 of 16. So don't do the property we were just talking about, because that's going to make your life harder. You just want to say, what's log base 2 of 16? So remember, logarithms, they always ask the question, what power do you need to raise this to? What power do you need to raise 2 to get 16? And hopefully you see that's 4. So this log base 2 of 16 is 4. So this is just 3 times 4. So it's 12. Alternatively, you could do the opposite of that property, where you rewrite this log base 2 of 2 to the 4th, and then you can move that out to the front. So then it's 4 log base 2 of 2, with that 3 still being there. And then log base 2 of 2, if these numbers are the same, you always know that's just 1. So that just goes away, and it's just 3 times 4. Alright, a bag contains several marbles. On 3 successive draws with replacement, a red marble is drawn from the bag each time. Which of the following statements must be true about the marble in the bag? Oh, that's interesting. Okay, a bag contains several marbles. On 3 successive draws with replacement, so they take it out and they put it back in every time, a red marble is drawn from the bag every single time. Which of the following statements must be true? Well, F must be true. So I definitely like F a lot. Exactly 1 marble is red. No, they could all be red. They didn't say anything about that. Exactly 3 marbles are red. If there was no replacement, then it would be exactly 3 marbles are red. But they're taking the red one out and they're putting it back in every time. So that doesn't need to be true. All of the marbles are red. I guess it doesn't say how many marbles are in the bag, does it? But no, we don't need that to be true. The bag contains more red marbles than other marbles. No, none of those has to be true. All that is true, based on what they told us, is that there has to be at least 1 marble. All right. Whoa, we got a big one now. Students and adults from Western High School visit an amusement park on a field trip. I don't know why I'm reading that. We don't need to read that. Which of the following values is closest to the total distance traveled in miles during one complete ride on the roller coaster? Okay, maybe we do need to do it. So the amusement park charged $25 before the trip to give information. Okay, the average speed of the roller coaster is 50 miles per hour. And what ride on the roller coaster takes 2.25 minutes? Right. So all we have to do there is go from 2.25 minutes to miles. So that's just the dimensional analysis. Make sure you're starting in minutes. So the first one is you've got to go from minutes to hours. And then it's 50 miles per hour. So the hours are canceling, the minutes are canceling. We have a calculator, so it's going to be 2.25 times 5 divided by 6. 1.875 miles. That's long as heck. That is a long roller coaster, ain't it? I think so. So now number 36. The roller coaster is at a height of at least 235 feet for a total of 5 seconds during each complete ride. Which of the following is closest to the percent of time during the complete ride that the roller coaster is at a height of at least 235 feet? The roller coaster is at a height of at least 235 feet for a total of 5 seconds during each complete ride. Which of the following is the closest to the percent of time during a complete ride that the roller coaster is at a height of at least 235 feet? So we're just looking at the 5 seconds out of how many seconds there were. Except I'm actually, for whatever reason, I'm going to put this into... So we have 5 seconds. There's 60 seconds in a minute. So now we're in minutes. And so now I can just divide by how many minutes there were. That's a tiny percent. That's like 1%. 5 divided by 60 times 2.25. Except for 2.25. No, it's 3%. It's almost 4%. Yeah, 4%. Okay. Which of the following values is closest to the average slope in feet per second of the graph on the interval between 40 and 90? Okay, so that's the straight up part. So yeah, what's the slope? I'll say it's going from 50 to 250. So it's going up 200 while it's going over 50. So that's a slope of 4. Up 200 over 50. Slope of 4. All right. So the value of x to the 5th times all of that is between the following numbers when x equals 10. Well, that's weird. I'm just going to plug that into the calculator and see what the calculator tells me. So 10 squared times 0.5. Oh, it's not 10 squared, though. It's 10 to the 5th. Point 0.5 10 squared plus 2.5 times 10 plus 6. Syntax error because I didn't close the parentheses. Right, and then I would just put that back into scientific notation. So I'd have to move over 1, 2, 3, 4, 5, 6. So it's 8.1, 10 to the 6th. That makes sense. So that's right here. That's like right on the edge. I want to make sure I type that in right. 0.5 10 squared, 2.5 times 10 plus 6. Yeah, that's right. Okay. For which of the following data sets is the difference between the mean and the median the greatest? So the biggest outlier is going to have the biggest difference. So I'm sure it's going to be D. Well, no, I can definitely tell it's going to be D. because the average is going to be massive there. I mean, here they're both the same. Here, they're actually also both. Well, they're not both the same here, but they have a very small difference here. Here, they're, again, even smaller difference. D is going to have the biggest difference. E is not going to have the biggest difference because this is already 55, whereas the average here is 105. But for 10, well, the average is definitely not 105. I don't know what I'm talking about there. It's 55. Oh, wait, that has the same average. Those are the same. So that's not good either. But it's definitely D, because the whole idea is that the mean always pulls up the median. So that's definitely D. Yeah. All right, next. Ooh, a geometry problem. Pablo has a deck and pool in his backyard. The deck shape is a rectangle with the semicircle removed and is shown shaded in the figure below. The lengths of the straight sides of the deck are given in feet. Pablo plans to cover the top of the deck with a stain. To decide how much stain he will purchase, he needs to find the area of the top of the deck. What is the nearest square foot of area of the top of the deck? All right, that's easy enough. So we want to find the radius of the pool so we can find the area of that semicircle. So what is the radius of that pool? Well, you look how you got these 4s on the edges, and then this 32 right here. So that whole length is 32, but then you take away the 8 for the edges. So that means that whole diameter is 24. But then when we find the area of the pool, we need to use the radius, which is half of the diameter, which is 12. So that means the area of the whole pool is 12 squared times pi, but we only want half, so we got to divide it by 2. So that's 72 pi. And then we got to find the area of the whole deck. The whole deck is just 20 times 32, right? Or the whole rectangle. So you're going to do 20 times 32, which is 640, minus 72 pi. And there we go. What is that? 640 minus 72 pi. Are we sure the circle is centered on the left edge of the rectangle? Well, it has to be. Yeah, they said semicircle. That's how we know that. So yeah, then the answer should be 414. I was just told that the sound was awful for the whole last problem here. So I hope we got the end of that. Hopefully the important parts. Let's go back to this. So what we were saying is that it's a similar idea as the last one. I know you got to see it, and so that was kind of the critical stuff, is that we got this 3 here and this 3 here. So if the whole thing is 30 and those little bits are 3, you got to take those off to get what the side of the pool is. So 30 minus 6, 24. Same idea with the 40. There's still 3 wide, so you got to take off that 6. So that's 36. No, silly me. You're taking off the 6. So that's 34. So now to find the perimeter, you just got to get all those together. So add all 4 of these sides. You got 2 of them that are 24, 2 of them that are 34. So what's going to be easier for us is to add those together. 58 multiplied by 2, 116. Beautiful. So now 42, which we also did earlier, you see what we have. We have f of x inside of the parentheses. So that means that that is what you're plugging in for x. So you're taking this f of x, x squared, and you're getting rid of that x there and replacing it with x squared. So what do we have now? 1 over 4 minus x squared. The stuff like that trips a lot of people up. That's important. All right, next, a circle has a circumference. So circumference is 2 pi r of 2 pi root 2 equals 2 pi root 2. So what is the r? Well, the r is root 2. So then they ask about the area. Well, the area is pi r squared, so it's pi root 2 squared. So those are canceling. So it's simply 2 pi. Next, now I'm all paranoid about my microphone. Next, in the standard xy coordinate plane, the coordinates of the y-intercept of the graph of the function y equals f of x are x equals -0 and -2. What are the coordinates of the y-intercept of the graph of the function f of x? -3. So this is transformations, one of my least favorite topics to teach. But the idea of transformations is that -3, what does it do? It just moves everything down 3. So if your y-intercept was here at 0, -2, you're going to subtract 3. It's going to go down 3, and so now it's going to be at -5. All right, last one for today. Which of the following is an equation of the parabola that passes through the 3 points? Very nice. So we're looking at these equations. So the first thing I'm going to see is we have our intercepts, 3 and -3. So that means we need the factors x plus 3 and x minus 3. That one for that one, that one for that one. So let's see which ones we have those for. We have that for the first one. We have that for the second one, but it's x minus 3 squared. So that's not even going to be a parabola because that's going to be x cubed. Same with the next one and the next one, actually. And then we do have it on the next one. Wait, why did I cross out A? No, A is good. It's either we crossed out B, C, and D. A was fine. B, C, and D are wrong because they're not parabolas. They're squared. So the next thing is how do you get the 0, 3? Well, actually, no. The next thing is see how it's an upside-down parabola. If it's an upside-down parabola, that means it's negative. So you choose the negative one here at A. So I just look at the x-intercepts and I just look at the sign. And that's all for our ACT today. So hope you enjoyed that. Hope you come back for us to finish later.